18th question. Find the sum to n terms of the sequence 8, 88, 888, dash dash dash. Solution. Sn is equal to 8 plus 88 plus 888 plus dash 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 n terms. Is equal to if you take 8 by 9 common, then you will get 9 plus 99 plus 999 plus dash 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 n terms. Because when you take 8 common, so then you will get 1 1 1 plus 1 1 1 plus dash dash dash. So when you multiply by 9, you will get 9 plus 99 plus 999 plus dash 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 n term. To balance that, you have to divide by 9 is equal to 8 by 9. 9 can be written as 10 minus 1 plus 99, 10 square minus 1 plus 999, 10 cube minus 1 plus dash 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 n terms is equal to 8 by 9 into, let us write 10 plus 10 square plus 10 cube plus dash 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 n terms minus 1 plus 1 plus dash 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 n terms is equal to 8 by 9 into, this is a ZP with the first term 10 and common ratio 10. Sum is 10 into 10 raised to the power n minus 1 divided by 10 minus 1 minus n is equal to 80 by 9 into 9, 81 into 10 raised to the power n minus 1 minus 8 by 9 into n. Question number 21. Find 4 numbers forming a geometric progression in which the third term is greater than the first term by 9 and the second term is greater than the fourth by 18. Solution. Let A, AR square and AR cube be the four numbers of a GP. According to the problem, third term is, that is AR square is greater than first term by 9. This implies AR square minus A is equal to 9 implies A into R square minus 1 is equal to 9, say number 1. And second term, that is AR, is greater than the fourth term. What is fourth term? AR cube by 18. This implies AR minus AR cube is equal to 18. Implies when you take minus AR common, then we will get R square minus 1 in the bracket is equal to 18, say number 2. Dividing 2 by 1, we get minus AR into R square minus 1 divided by A into R square minus 1 is equal to 18 divided by 9. This implies R is equal to minus 2. Substituting R is equal to minus 2 in 1, we get A into R square 4 minus 1 is equal to 9. This implies A is equal to 9 by 3 is equal to 3. Therefore, required numbers are 3 minus 6, 12 and minus 24. Question number 23. If the first and the nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square is equal to AB whole raised to the power n. Solution. Given that first term is equal to A and an is equal to B, this implies A into R raised to the power n minus 1 is equal to B, implies R raised to the power n minus 1 is equal to B by A. Say number 1. Therefore, product of n terms, that is P, is equal to A into AR square into dash 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 A into R raised to the power n minus 1 is equal to A into A into A into A n times into R into R square into R cube into dash 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 into R raised to the power n minus 1. This is equal to A raised to the power n into R raised to the power 1 plus 2 plus 3 plus dash 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 plus n minus 1 is equal to A raised to the power n into R raised to the power sum of first n minus 1 natural numbers, that is n into n minus 1 divided by 2 is equal to A raised to the power n into, let me write R raised to the power n minus 1 whole raised to the power n by 2. Is equal to A raised to the power n into R raised to the power n minus 1 is B by A whole raised to the power n by 2 is equal to A raised to the power n minus n by 2 into b raised to the power n by 2 is equal to a raised to the power n by 2 into b raised to the power n by 2 is equal to ab whole raised to the power n by 2. This implies p square is equal to, when you square both sides, you will get ab whole raised to the power n. Question number 27. Find the value of n so that a raised to the power n plus 1 plus b raised to the power n plus 1 divided by a raised to the power n plus b raised to the power n may be the geometric mean between a and b. Solution. According to the problem, a raised to the power n plus 1 plus b raised to the power n plus 1 divided by a raised to the power n plus b raised to the power n is equal to square root of ab. That is the geometric mean between a and b. Is equal to a raised to the power 1 by 2 into b raised to the power 1 by 2. This implies by cross multiplication we will get a raised to the power n plus 1 plus b raised to the power n plus 1, we can write as it is equal to a raised to the power n plus 1 by 2 into b raised to the power 1 by 2 plus a raised to the power 1 by 2 into b raised to the power n plus 1 by 2. This implies a raised to the power n plus 1 minus a raised to the power n plus 1 by 2 into b raised to the power 1 by 2 is equal to a raised to the power 1 by 2 into b raised to the power n plus 1 by 2 minus b raised to the power n plus 1. This implies if you take a raised to the power n plus 1 by 2 common, then you will get a raised to the power 1 by 2, because a raised to the power n plus 1 by 2 plus 1 by 2 is nothing but a raised to the power n plus 1 minus b raised to the power 1 by 2 is equal to, let us take b raised to the power n plus 1 by 2 common, this we can write as b raised to the power n plus 1 by 2. Then a raised to the power 1 by 2 minus b raised to the power 1 by 2. This implies, let us bring b raised to the power n plus 1 by 2 left side. Then we will get a by b whole raised to the power n plus 1 by 2 is equal to 1. This 1 can be written as a by b whole raised to the power 0. This implies n plus 1 by 2 is equal to 0, implies n is equal to minus 1 by 2.